In this video, we're going to look at solving log equations. These questions, let me write down where they come from. This comes from page 15, this page 33, and page 34. I categorize them as log equations because, well, explicitly in the level 2 questions, page 33 and page 34, they're actually called log equations. But you can see that page 15, question 23, follows a similar format. What are these log equations? Is when you have an equation that involves a log in it. That's it. But not all terms will be log expressions. For example, you will still see integers like these zeros and integers here. So we're going to talk about what to do with them. So you know that you can use the log properties like addition, subtraction. But let's first talk about what do we do with the integers. For example, here, this 1, we don't leave it as 1. And please note that it is not log bracket x minus 1. Because there's no bracket, what it really means is log x and then minus 1. These are two separate terms. So what do we do to this 1? We can turn it to log 10 because this is a base 10 question. And then now, because these two are both log expressions, right? Terms involving log, then we can combine them using the log property. So next we have log y equals log x over 10, which is the log property. And now at this point, when we have log something equals to log like one term, okay, then we can cross out the log like this, cross it out, and we know that y is equal to x over 10. So when we need to express x in terms of y, x will be 10y. So basically we're doing this with all the questions in the same manner. Here, 2 is not log 100 because here this is a base 3 question. So we will change this 2 to log 9 base 3. Okay, similar. In a very similar manner, we'll do all these questions. So this 2 can go up to become a y square, which is the log property 3. So although in question 23, you are not really solving for x, okay, but you are expressing x in terms of y, this is kind of like change of subject, but they're all of the same kind, I would say, okay? If these questions are base 10, then you try to rearrange them so that it becomes log one thing that is equal to log the other thing. Okay, so here we can move the 2 to become the square of 5. And now because there is only like one term following the log, now we can start crossing the term out. So it's 6 minus x that is equal to 25. But for log equations, always remember to check whether your x makes the equation valid. You need to substitute the x into that bracket or expression following log to ensure that it does not return a negative value. All right, then there are some that require base changing. For example, in this question, these two terms are of different bases, then we cannot directly apply the log properties, then we will need to change them. So I will tend to change the larger base to the smaller one, okay? So we know that log 2x, log x base 2, log 8 base 2, and this number is 3, right? So it's 1 over 3 log x base 2, and now these two are like terms, okay? Note that these two terms are like terms, so it becomes negative 2 over 3 log x base 2 that is equal to negative 4, okay? So now we're solving this equation here. So by rearranging, we know that log x base 2 is 6. So x is 2 to the power 6, which is 64. Okay. So just look at what you've done previously in the homework questions or in the worksheets, we have actually covered a lot of this. So once again, for log equations, what you are trying to do is to apply the log properties, okay, until you get to some log, for example, 2 equals log 2 something. And then from there, you can cross out the log and just equate these two boxes. Okay, and then equate these two boxes. It doesn't have to be log 2, it could be just log a whatever, okay? As long as they're of the same base, then you can cross out the log and then equate what follows. And that's how you are going to get rid of the log and solve for x.